The next concentration term is parts per million. If the concentration of solute is very small, if the solute is present in traces, then we use this term parts per million. So why we use this term parts per million? Because if the solute concentration is very less, you cannot find any amount of solute in 100 parts. Okay? In 100 parts, the amount of solute is minute or it is negligible. So that's why we use the amount of solute present in millionth part of the solution. So how do you calculate this term parts per million? The formula is very similar to the previous one. Here we take number of parts of the components to the total number of all the components into 10 to the power of 6. Here number of parts of the component. So here you can express this parts as mass or volume. Here no need to take the number of parts always. Here now instead of taking number of parts, we can take mass of the component to total mass of all the components in millionth part of the solution. So here we can write it as W by W into 10 to the power of 6 or V by V into 10 to the power of 6 or mass by volume into 10 to the power of 6. So this is about parts per million concentration term. So when we use this term, if the concentration of solute is very less or negligible, so then we are going for more amount of solution, that is 10 to the power of 6th part of the solution. We are finding the amount of solute. The next term, fifth concentration term is mole fraction. You studied this concentration term in your first PUC classes. So how do you define mole fraction? Its symbol is small letter x. It's denoted as x. So mole fraction is equal to number of moles of component divided by total number of moles of all the components. Total number of moles of all the components or total number of moles of components. I will give you one example. You take two components A and B in the solution. There are two components in the solution A and B. We have n of A moles of A and n of B moles of B in the solution. N of A moles of A, n of B moles of B is present in the solution. Now, if you want to calculate the mole fraction of component A, first component A, we write the formula like this, x of A. That means mole fraction of component A. X of A is equal to number of moles of that component A. It is n of A. It's given. Number of moles of component A is how much? It is Na. Divided by total number of moles of components. Total number of moles of component. There are only two components, A and B. Number of moles of A is Na. Number of moles of B is Nb. So total number of components, moles of components is equal to Na divided by n of A plus n of B. So this is how you calculate the mole fraction. Similarly, for component B, you apply the same formula. Mole fraction of B is given by number of moles of component B divided by total number of moles of all the components or total number of moles of components, n of A plus n of B. So this is for the binary solutions. You understood? So formula is simple, number of moles of component divided by total number of moles of components. Now sometimes we have solutions with I number of components. There are I number of components. There are many components in the solution. Now how do you calculate the mole fraction of ith component? We write it as xi. Mole fraction of ith component is written as xi. Here it is written xi is equal to number of moles of that component. It's Ni or n of I divided by total number of moles of components. You add all the number of moles of components, N1 plus N2 plus N3 up to Ni. So this is how you calculate the mole fraction of ith component. Understood? Yes. The last thing is the sum of the mole fraction of all the components in the solution is always equal to 1. It may be having I number of components, or sometime it may have only two components, 1 and 2. So here x1 plus x2 is equal to 1. Always it is equal to 1. Here if it has I number of components, then x1 plus x2 plus x3 up to xi is equal to 1. Sum of mole fractions of all the components present in any solution is always equal to 1. It may be a binary solution or that solution may have I number of components. So this is about the fifth concentration term, mole fraction. The next concentration term, the sixth concentration term is molarity, which is the most widely used concentration term in our chemistry. So you know the definition of molarity, you studied in your first PUC classes also. Molarity is defined as number of moles of solute divided by volume of solution in liter. Number of moles of solute divided by volume of solution liter. And this is denoted as capital letter M. It is a symbol for molarity. And its unit is mole per liter. Can write like this. Let us see how to prepare these molar solutions. I will give you the examples for the preparation of molar solutions. For example, if you take 1 molar solution of NaOH, you take 1 molar NaOH solution. What do you mean by 1 molar NaOH solution? 1 molar means 1 mole per liter of NaOH. You dissolve 1 mole of NaOH in 1 liter of water. When you dissolve 1 mole of NaOH, 1 mole of NaOH in 1 liter of solution or in water or in any solvent, you will get 1 molar solution. So how to dissolve this 1 molar or 1 mole NaOH? How do you dissolve 1 mole NaOH? How to dissolve it or how to get 1 mole of NaOH? 1 mole is nothing but 40 gram of NaOH. How do you know 40 gram is equal to 1 mole? 40 gram of NaOH is equal to 1 mole. You know the formula for that. There is a formula. N, number of moles, is equal to mass divided by molar mass. Mass divided by molar mass. You have taken 40 gram of NaOH. You have taken 40 gram of NaOH to dissolve in 1 liter of water. So 40 gram means how many moles? You calculate. N is equal to number of moles is equal to mass is how much? 40 gram you have taken. So molar mass of NaOH, that is also equal to 40 gram. So the number of moles is equal to 1 mole. If you dissolve this 1 mole in 1 liter, you will get 1 molar solution or 1 mole per liter solution. 1 mole per liter solution. Okay, one more example. How do you prepare 0.5 molar of glucose solution? How do you prepare 0.5 molar of glucose solution? How to prepare it? In order to prepare 0.5 molar glucose solution, it's very simple. You have to dissolve 0.5 mole of glucose in 1 liter of water. You have to dissolve 0.5 mole of glucose in 1 liter of water. So 0.5 mole means how much gram of glucose we have to dissolve. How do you know that? Again, we know the molecular mass of glucose. The molecular mass of glucose is how much? It is equal to 180 gram. So molar mass or molecular mass of glucose in gram. So 180 gram. So 180 gram means 1 mole. You directly calculate it. 180 gram means 1 mole. So 0.5 mole means how much? It's 90 gram. So 90 gram of glucose means 0.5 mole. Here, if you dissolve 90 gram of glucose in 1 liter of water, if you dissolve 90 gram of glucose in 1 liter of water, you will get 0.5 molar glucose solution. This is the method of preparation of molar solutions. It's the method of preparation of molar solutions. Next, this molarity concentration term has volume in its denominator. So this volume is temperature dependent. Volume is temperature dependent. It depends upon the temperature. As temperature increases, as T increases, as temperature increases, volume of the solution increases. Volume increases. As volume increases, the molarity of solution decreases. Molarity of solution decreases. Next, as temperature decreases, volume decreases, molarity of solution increases. So here, molarity varies with temperature. Molarity varies with temperature. That means this term cannot be used in some experiments which has change in temperature. So in the reactions in which if there is any change in temperature, then molarity of that solution or reaction mixture also changes. That means as temperature increases, molarity decreases. As temperature decreases, molarity increases. Means molarity is inversely proportional to temperature. It varies inversely with temperature. This is important for 1 mark. They will ask how molarity of solution is related to temperature. As temperature increases, volume increases. As denominator increases, the whole term decreases. So this is how do you calculate. Okay. The last concentration term is molality. So which is denoted as small letter m. What's the difference between molality and molarity? You can see the difference. You studied it in your first PUC classes also. The numerator remains the same. It's number of moles of solute. But in the denominator, we have taken mass of solvent in kg. But mass is a temperature independent term. It does not change with the temperature. That's why in the reactions, if there is any change in temperature, in such cases, we use molality as a concentration term. While measuring colligative properties, we use this term and its unit is mole per kg. So one example I will give you. How to prepare 0.1 molal NaOH solution. 0.1 molal NaOH solution. You studied how to prepare molar solution similar way. You dissolve 0.1 mole of NaOH. 0.1 mole of NaOH in 1 kg of water. 1 kg of H2O or water. So you will get 0.1 molar solution. So 0.1 mole means how much gram of NaOH we have to dissolve. So 1 mole means how much? 40 gram. You know that. 1 mole means 40 gram. 0.1 mole means 4 gram. If you dissolve 4 gram of NaOH in 1 kg of water, you will get 0.1 molal. 0.1 molal, small letter m it is. 0.1 molal sodium hydroxide solution. So this is the difference between molality and molarity. Here it is volume and here it is mass. Okay, this is about the concentration terms.